Okay, so my presentation is on arthropods. So there are three different classes, well, there's three different subphylums slash classes. They're not the same thing, but it's kind of mixed up a little bit. So the first one is Myripodia. So this would be like centipedes. So they have many different body segments. As you can see in a centipede, the thing is it's really big, it's really long. So it has a bunch of different body segments, like 100. It really varies per animal, or I should say arthropod. So there's 1 to 2 legs per segment. The last segment, I believe there are 4. There are 2 sticking out the side and then 2 sticking out the back. So to move on to arachnids now. So they have no antenna. This is really strange for an arthropod because usually the determining factor for an arthropod is that it must have an antenna. But arachnids do not have antennas. So they usually have 6 appendages, not 6 pairs of appendages. An example of this would be spiders, scorpions, and arthropods like that. And then the third one is crustaceans. So since crustaceans, there are 30,000 different species. They're so diverse. And there's so many different characteristics for all these different species. The only way to determine whether or not it's a crustacean is it must have 2 antennas. So an example of this would be a lobster or a crab. So how do you identify an arthropod? Well, it must have body segments. So this is also an appendage. So they have a jointed leg, and this is part of the appendage. So it's a body part, and then there's a jointed leg attached to it. So another way to determine if it's an arthropod is its exoskeleton. There are 3 layers. There's a waxy outer layer made up of a mixture of proteins and lipids. So this keeps water out. It also keeps water in. So no water is escaping out through the body or through the arthropod's body, and it keeps the animal from drying out. So the middle layer provides primary protection. It's made of protein and chitin. Chitin is a tough polysaccharide that keeps it tough, and it's able to defend against predators and also fight back and capture prey if it needs to. So the inner layer, the inner layer is basically the same thing as the middle layer. It's made up of protein and chitin, and it is more flexible than the middle layer because the animal needs to move around when it does not have its middle exoskeleton on when it's molting. So this is American crab. It is the heaviest arthropod that we know of right now, currently, and it is a crustacean. And how do we tell it's a crustacean? Well, we can tell it's a crustacean because it has these 2 antennas right here, and that's the determining factor whether or not it is a crustacean. And it has these jointed legs as well, so we also know that it's an arthropod, and it has body segments or appendages. So we know from the jointed legs and the body segments that it is an arthropod. And to go further into determining its subphylum slash class, we know it is a crustacean because of its antennas. So how do what are the arthropods' interactions with humans? Well, in many cases, they access food. We have lobsters, which people eat lobsters, crabs. Going to this a little bit later, there's usually crabs are grabbed right in between, lobsters and crabs are grabbed right in between they molt and lose their exoskeleton and gain a new one. So some are harmful. Spiders, scorpions. In the Midwest, the 2 most dangerous would be black widows and the brown recluse. So some centipedes in the Amazon are dangerous and can be almost deadly. Scorpions, very few actually have venom, but when they do have venom, they're very, very dangerous. Mites and ticks. So mites are more dangerous to like livestock, bees, cows, chickens, stuff like that. And the ticks are a lot more dangerous to humans. They carry Lyme disease, which will affect you for your entire life. So you need to be very careful going to forested areas. And the Rocky Mountain spotted fever. I don't know what this is, but it's part of the disease that ticks carry. So this is a black widow spider, and how do I know it's a black widow spider? Well, it's first it's black, hence the name black widow spider, and also this red hourglass shape right here. This determines that it is a black widow spider, and it's very dangerous. And then this is a brown recluse. How do I know? It's because of this black piece right here. It is called the violin spider because it's kind of shaped like a violin. So next slide. Molting. I talked about this earlier with the crabs and getting a crab at the right time. so that the crab is ready to eat and easier to eat. So what is molting? So the exoskeleton becomes rigid and it won't allow the arthropod to grow anymore, so it has to shed the actual exoskeleton for the animal to continue growing and get a new exoskeleton that'll let the animal continue to grow. So how does it happen? So pressure builds up in the exoskeleton because the exoskeleton is too small and there's a lot of pressure. So this produces a hormone that triggers molting. So in response to this hormone being triggered, enzymes are created to digest the inner layer of the exoskeleton. So it breaks down the inner layer of the old exoskeleton and takes the materials to form the new exoskeleton. So eventually, the outer layer of the old exoskeleton breaks and it is shed by the arthropod. And so it becomes loose and it sheds, and the arthropod breaks. And this is why it has that inner layer that I was talking about earlier, so it can navigate out of this. And so the new exoskeleton is flexible at first, so it can stretch around to fit the new arthropod's exoskeleton. And so it's kind of like the inner layer at first, but then it changes later. So the new exoskeleton takes a few hours to a few days to become as hard and as protective so that it can defend against predators as the first exoskeleton. So this time period is actually 80 to 90% of the cause of all arthropods' deaths, which is really crazy. So that's the end of my presentation. Thank you.